This simulation shows a property of waves known as refraction. It occurs when a wave travels from one material into another. In this case, we're looking at red light traveling from air into glass. Before really getting started though, I'd like to mention one point that is often ignored. Whenever you get a refraction, down here, you also typically get a reflection as well. And the energy split depends quite strongly on the angle of incidence. Here this energy meter is showing that 90% of the light is traveling into the glass. If I decrease the angle of incidence to make it really small though, that means almost all of my energy travels into the glass and my reflection will be very faint and barely noticeable. But on the contrast, if I make a very, very, very big angle of incidence, most of my light reflects, and so very little will travel into my new material. This does have various implications for the design of many devices, such as telescopes. Anyway, back to refraction. It is caused when light travels from one material into another one, usually from something like air, into a material that is harder for it to travel through. This means that the light will slow down when it enters the new material, in this case glass. Turning on this little speed tool shows us that here the light is traveling at about 2/3 of the speed of light in air. In other words, it's a fair bit slower. Now, for most school purposes, this isn't really the main focus, although it is the underlying cause. What we're usually much more interested in is just the angles. So the angle of incidence here and how it relates to the angle of refraction. There is a general rule, and that rule is that the angle in the material that's harder to travel through will always be much smaller. In this case, it goes from 42 degrees roughly in air to about 26 in the glass. Now I can change this angle and I get various different appearances, but what's always true is that my angle in air is bigger than the angle in the glass. This works for every material. Different materials have a different amount of effect. We say that every material has a refractive index or an index of refraction. In this case, glass has a value of about 1.5, meaning that light is 1.5 times as slow in the glass. If I change this slider, what that does is it changes which material we have here on the bottom. I can make it so that the material is a bit more like air, in which case you only get a small change in the angle, there's very little refraction going on, or I can make it so the angle of refraction is much, much higher. Different types of glass, for example, have higher or lower refractive indexes, and oil and many other materials has that as well. The second thing that affects this is the color of the light, which is really the wavelength. So if I choose a convenient size, we can exaggerate this effect a little bit. If I look at the case of red light and I choose an angle of incidence of about 80, I get 41.1 degrees inside the glass. But if I choose a different color of light, if I swap my red laser for a green laser, it's now just 40.9, and if I go for a blue laser, it's only 40.6. This is quite a small angle change, but it's the effect that's responsible for things like rainbows. We use this when we have telescopes studying distant stars or spectrometers studying chemicals.